Hello everyone, welcome to my lecture. The goal of this lecture is to teach you to think like a computer scientist. This way of thinking combines some of the best features of mathematics, engineering and natural science. Like mathematicians, computer scientists use formal languages to denote ideas, specifically computations. Like engineers, they design things, assembling components into systems and evaluating trade-offs among alternatives. Like scientists, they observe the behavior of complex systems from hypotheses and test predictions. The single most important skill for a computer scientist is problem solving. Problem solving means the ability to formulate problems, think creatively about solution, and express a solution clearly and accurately. As it turns out, the process of learning to program is an excellent opportunity to participate problem-solving skills. That's why this lecture is called The Way of the Program. On one level, you will be learning to a program, a useful skill by itself. On another level, you will use programming as a means to an end. As we go along, that end will become clear. First, we will learn about the Python programming language. The programming language you will be learning is Python. Python is an example of a high-level language. Other high-level languages you might have heard of are C, C++, Perl, and Java. As you might infer from the name high-level language, there are also low-level languages, sometimes referred to as machine language or assembly languages. Loosely speaking, computers can only execute programs written in low-level language. Those programs written in a high-level language have to be processed before they can run. This extra processing takes some time, which is a small disadvantage of high-level languages, but the advantages are enormous. First, it is much easier to program in a high-level language. Programs written in a high-level language takes less time to write. They are shorter and easier to read, and they are more likely to be correct. Second, high-level languages are portable, meaning that they can run on different kinds of computers with few or no modifications. Low-level programs can run on only one kind of computer and have to be rewritten to run on another. Due to these advantages, almost all programs are written in high-level languages. Low-level languages are used only for a few specialized computers or applications. Two kinds of programs process high-level languages into low-level languages. First one, the interpreters. I will show you in this slide. There is interpreters, and the second one is compiler. There it is. An interpreter read a high-level program and execute it, meaning that it does what the program says. It processes the program a little at a time, alternately reading lines and performing computations. A compiler reads the program and translates it completely before the program starts running. In this case, the high-level program is called the source code, and the translated program is called the object code or the executable. Once a program is compiled, you can execute it repeatedly without further translation. Python is considered an interpreted language because Python programs are executed by an interpreter. There are two ways to use the interpreter: command line mode and script line mode. In command line mode, you type Python programs and the interpreter prints the there is the result. There is a code. You see, this is the code. The first line of this example is the command that starts the Python interpreter. There it is, this Python. The next two lines are messages from the interpreter. There is the two lines, this one and this one. The third line starts with this, which is the prompt the interpreter uses to indicate that it is ready. We typed print 1 plus 1 and the interpreter replied 2. This is. Alternatively, you can write a program in a file and use the interpreter to execute. The contents of the file, such a file is called a script. For example, we used a text editor to create a file named latoya.py with the following contents. First, we will write print 1 plus 1. By convention, files that contain Python programs have names that end with .py. To execute the program, we have to tell the interpreter the name of the script. That is the first line Python, and you have to say the name of the script latoya.py, and next you will have to say, or you will have to type 2. In other development environments, the details of executing programs may differ. Also, most programs are more interesting than this one. Most of the examples in this lecture, or I will show in my lecture, are executed on the command line. Working on the command line is convenient for program development and testing, because you can type programs and execute them immediately. Once you have a working program, you should store it in a script so you can execute or modify it in the future. The next lecture we will discuss about what is program and the other things. Thank you everyone. Hello there. Welcome to my lecture. Today I will discuss about the dictionaries. The compound types you have learned about: strings, list, and type tuples use integer as insiders. If you try to use any other type as an index, you get an error. Dictionaries are similar to other compound types except that they can use any immutable type as an index. As an example, we will create a dictionary to translate English words into Spanish. For this dictionary, the indices are strings. One way to create a dictionary is to start with the empty dictionary and add elements. The empty dictionary is denoted as second bracket. This one. The first assignment creates a dictionary named English to SP. The other assignments and few elements to the dictionary, we can print the current value of the dictionary in the visual way. The elements of the first assignment gets a dictionary named English to SP2, and the elements of a dictionary appear in a comma separated list. Each entry contains an index and a value separated by a colon. In a dictionary, the indices are called keys, so the elements are called key value pairs. Another way to create a dictionary is to provide a list of key value pairs using the sample syntax as the previous output. The key value pairs are not in order. Fortunately, there is no reason to care about the order, since the elements of a dictionary are never indexed with integer indices. Instead, we use the other keys to look up the corresponding values. The key 2 yields the value DOS even though it appears in the third key value pair. Now we will discuss about the dictionary operations. The del statement removes a key value pair from a dictionary. For example, the following dictionary contains the names of various fruits and the number of each fruit in stock. The inventory: apple, bananas, orange, pears, etc. If someone buy all of the pairs, we can remove the entry from the dictionary by this one. Or if we are expecting more pairs soon, we might just change the value associated with pairs with this one. The len function also works on dictionaries and returns the number of key value pairs. Now we will discuss about the dictionary methods. A method is similar to a function. It takes parameters and returns a value, but the syntax is different. For example, the keys method takes a dictionary and returns a list of the keys and the pair. But instead of the function syntax keys English to sp, we use the method syntax English to sp.keys, like this one. This form of dot notation specifies the name of the function, keys and the name of the object to apply the function to English to sp dot. The parenthesis indicated that this method takes no parameters. A method call is called an invocation. In this case, we could say that we are invoking keys on the object English to sp. The values method is similar. It returns a list of the values in the dictionary, like this one. The items method returns both in the form of a list of tuples, one for each key value pair. This is like this one. The syntax provides useful type information. The square brackets indicate that this is a list, parentheses indicate that the elements of the list are tuples. If a method takes an argument, it uses the same syntax as a function call. For example, in method has key takes a key and return true if the key appears in the dictionary. If you try to call a method without specifying an object, you must get an error. Then we will discuss about aliasing and copying. Because dictionaries are mutable, you need to be aware of aliasing. Whenever two variables refer to the same object, sets to one affect the other. If you want to modify a dictionary and keep a copy of the original, use the copy method. For example, opposites in a dictionary that contains pairs of opposites. Then you have to type this one. Alias and opposite refer to the same object. Copy refers to a fresh copy of the same dictionary. If we modify alias, opposites is also changed. This one. If we modify copy, opposites is unchanged. This one. Now we will discuss about the other thing is sparse matrix. In my other lecture, we used a list to represent a matrix. That is a good choice for a matrix with mostly non-zero values. But consider a sparse matrix like this one, 0 0 0 1 0 and 0 0 0 0 0. This one. The list representation contains a lot of zeros. An alternative is to use a dictionary. For the keys, we can use tuples that contains the row and column numbers. Here is the dictionary representation of the same matrix. We only need 3 key value pairs, one of each non-zero elements of the matrix. Each key is a tuple and each value is an integer. To access an element of the matrix, we could use the operator matrix 0 3 1. The get method solves this problem with this one. The first argument is the key. The second argument is the value. Get should return if the key is not in the dictionary. Then get the definitely improves the semantics of assembling a sparse matrix. Shame about the syntax. If you play around with the Fibonacci function from another lecture, you might have noticed that the bigger the argument you provide, the longer the function takes the run. Furthermore, the runtime increases very quickly. On our machine, Fibonacci 20 finishes instantly, Fibonacci 30 takes about a second, and Fibonacci 40 takes roughly forever. Thank you for listening this lecture. Thank you everyone.